Alrighty, ladies and gentlemen, here we go. We are in section 11.4, actually, I believe. Yeah, not 11.5, 11.4. Sorry about that. But we're on worksheet 7-5. Okay, we'll be doing this for the next 2 days. So we are working on our last type of conic section, which is a hyperbola, okay? So hyperbola here, I have 2 different examples. Okay, we're going to talk about the key attributes of it, okay? You can see, right, it's cut, you can get it by cutting through a cone. That's why it's called a conic section. It's also, it has foci, just like you would have foci with a ellipse, okay? We're still gonna have a vertex. However, you will see that there are no co-vertices, okay? So your hyperbolas are what's in blue here, if you can see that. All right, there's 2, what looks like parabolas, but they are not parabolas, okay? But they do have that kind of similar curve to them. They go through the vertices. They do not go through these 2 points. They do not have a name, okay? I'm gonna call them the corners because they kind of help you create this box, which is gonna be important to our shape. But the vertex you're always gonna find, the foci you're always gonna find, okay? I usually put X's for those, as we do with an ellipse, all right? Then a big thing we're gonna talk about is the transverse axes, okay? That is the axes on which, it's kind of like the major axes that you're used to thinking about with an ellipse. It's the axes where, through which you have the vertices and you also have the foci, okay? So if you take a look here, okay, we have, this is our hyperbola, okay, the general form of it, okay, I should say the standard form, sorry, where we have the HK, all right, so this is still going to be your center, okay? So your center is still gonna be HK, all right? There is always subtraction between the 2 terms here, okay? So if you have subtraction, then that means we have a hyperbola, okay? If you have addition between the 2, then that means we have an ellipse, like we just graphed, okay? It should always be equal to 1, just like with an ellipse. And then we have the a squared and the b squared, just like we had with an ellipse. Now, here's the deal. This is very different than an ellipse. The a squared is always under the positive term. So our a squared here, you can see under the x minus h squared, because that's the positive term. The negative term would be the y minus k, because that's being subtracted, all right? And that's where the b squared would be, okay? The transverse axes, okay, is always parallel to the axes of the positive term, okay? So this guy, the transverse axes, is gonna be the x-axis, okay? So you can see your vertices, right, are actually on the x-axis. If we shift this up or down or left or right, your transverse axes would go through, okay, those vertices, all right, but it would always be parallel to that x-axis, all right? The way you're gonna find the foci is gonna be slightly different. If you remember with an ellipse, it was a squared minus b squared, okay, equals c squared. That was because the a squared was always bigger. That is not the case with a hyperbola and the values, all right? What's gonna happen here is you're gonna do a squared plus b squared equals c squared, which is the Pythagorean theorem. Because if you take a look here, can you see how the foci are now outside, right? Or outside of the, or I should say, a further distance from the center than the vertice. So therefore that length is going to be longer than a, all right? So it wouldn't make any sense if you did a squared minus b squared, okay? So here, another way to remember too is since this is subtraction, right? You always do the opposite thing with the a squared and the b squared. So since the hyperbola has subtraction, I'm adding a squared and b squared. If I'm working with an ellipse, and it's always addition between the h and the k, right, the terms, if that's addition, then I subtract the a squared and b squared. So it's always the opposite. That's how I remember it, okay? Then we also have asymptotes. So you can see here that the asymptotes, right, are going to go through the corners of this box, and I'll show you how to graph that. But do you see how I have dotted lines? And those asymptotes, right, are going to determine the width, okay? So these help determine width of hyperbolas, the hyperbola, okay? So if these had been, you know, closer together, then it would be a skinnier hyperbola, and I'll show you what I mean by that when we go to graph them, okay? Now, when we're writing the equation of those asymptotes, which you have to graph, just like with all our other shapes, we always have to graph the asymptote because it helps the graph to give, I should say, it helps to give the graph shape, okay? So when you go to graph those guys, you're gonna have to write the equation. Now, if you look, this x minus h is going to be the same x minus h as in your equation, okay? And then y minus k is going to be the same y minus k here. So if you recognize it, h and k are really your center, aren't they? So this is always the y coordinate of center, okay? And this guy is always the x coordinate. So I should write actually xy coordinate of center, okay? Because if you look, and this will make more sense when we do one, but do you see how it has to go through the center, okay? Your asymptotes, so it's the slanted lines that go through the asymptotes and the corners, okay? Then this change in y over change in x, right, is going to be our slope. Now, we're generally going to be graphing these guys. So your change in y from the center, because that's going to be the point that you're always going to have in your asymptote. If you go up and over, in this case, I went up b, didn't I? And over a. So this will be b over a, and it's always plus or minus because it's increasing as b over a, or it's also decreasing b and a, okay? So that always has a plus or minus, all right? So that's a ratio of b to a, okay? If we have an x-axis, right? If our transverse axis is parallel to the x-axis, all right? So if I change the equation ever so slightly, right, and I write it like this down at the bottom, right, you can see that x is now negative. Now, to be honest with you, you're usually going to see it written like this. The positive term is going to come first, okay, and then the negative term is going to come second, okay? But you can see, hopefully, that this has a vertical transverse axis, or in other words, what your book writes is the transverse axis is parallel to the y-axis. Okay, so this is our y-axis. If we shift this over or up, our vertices, right, are always from the center a distance up or down, okay? So a, again, is always under the positive term, okay? B is always under the negative term, okay? We're still using a squared plus b squared equals c squared. The only change here is our equation, right? When we go to do this, for the asymptote, is going to change slightly. It's still going to be y minus k equals plus or minus change in y for change in x. And then x minus h. So you're still going to have your shift, right? For the x's and the y's, same as you would with the center here, okay? So that doesn't change. The only difference here is if you look at this, when we create our, go through our center, right? And then we create these corners where we go through for the asymptote to create the asymptote. If I go up now, that distance up is actually a now. And then this is b, because the a is underneath the y, so that's how I'm increasing for my slope. So now, if you have parallel to the y-axis, then your slope is always plus or minus a over b. So it's the reciprocal of that. Now, you can memorize that rule, or when you go to graph it, you can just see that I'm counting, right, up b and over a, or up a and over b. It doesn't really matter. But it's always a ratio of a to b, depending on how you count the boxes, all right, when we graph. And I'll show you that in just a minute, all right? So this is a good sheet to keep track of, all right, and to help you on your homework. Let's take a look at 3 examples of graphing, okay? So if you take a look here, I can see these all, especially these 2, and then we'll get to that one. These are all hyperbolas because you can see here, this is in our standard form, it's equal to 1, and we have subtraction between the 2, okay? This one, to turn it into standard form, just like we did with an ellipse, this should be always equal to 1, okay? So if I divide through by 81, right, I will then just reduce this, and it will become x plus 4 squared over 81. Then minus, that reduces to y minus 1 squared over 9, and then equals 1, okay? So I have my subtraction, all right? This guy I can see is going to be the transverse, right? How is this hyperbola transverse? It's going to be parallel. Totally misspelled that, I'll fix it in a bit. 2, and since it's the y is the positive term, this is going to be parallel to the y-axis, okay? And then if I look at this one, okay, you see how the x is positive? This is going to be parallel, see I did that one right, to x-axis, okay? All right, so sometimes you might also see it written as transverse. The transverse axis is the y-axis, so y-axis transverse. And then x-axis transverse, that's another way to say it. But that's what you're looking for, okay? Now, vertices, let's take a look here. So my center, and the first couple you're gonna do on the homework are gonna have a center of 0, 0. I didn't do one like that because it's much easier, but you guys are gonna practice that first. So the first thing you're always gonna find is your center. So my center here is going to be -4, 2. Remember, be careful what comes first, right? So the negative term comes second, but that's my x-coordinate, so I should flip the sign, -4, and then this is a +2. That's my center. Second step, we already did, right, the way it's transverse. So that's going to help me find my vertices, which tells me that under the positive term, a squared is 81, so a is 9, okay? So now what I'm going to do is, when I graph this, -4, and then up 2, right? There's my center. Now I'm gonna go, because it's y-axis, right? I'm gonna go up and down because that's my transverse axes. So parallel to the y-axis. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my vertice. And then down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my other vertex, okay? Those are the only points that my hyperbolas are actually going to intersect, all right? So another way to do that is just to add 9 to the 2, right? And then subtract 9 from the 2. So your vertices should be -4. And then if we add 9, we get 11. And -4, right? And then we subtract 9, so then we get -7, okay? And you can see that graphically, or you could just do the math. All right, so we have that. Third step, I usually, and you'll see this on my answer key when you look at it, I just call this like the corners because they're not technically points on here. So the corners, right, are going to be like what would be the covertices of the ellipse, and that's using the b value. So my b value here, the b squared is 25, so b is 5. So I'm going to go out 5, 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So you need to graph those, okay, to get the corners of this, okay? So if I go out, this should be what? 1, 2, and then -9, 2, right? Because I went 5. Yeah, so that makes sense. Those are my corners, all right? So you're gonna find vertices, you're gonna find the center, okay? You don't technically have to state these, but you'll see it on my answer key. Then step 4, right? So now I'm gonna create that box. So do you see how I go horizontally, right, across till I get to that corner where directly vertical is that other corner point. So that's gonna create the box for me. So I'm gonna go down and then get parallel on the same horizontal line as that vertice, and then turn, right, intersect that, and then this, okay? So that's what my box looks like, right? So this creates the top of my box, right? However wide my box is, depending on those corners, right? That's how far I go, and then I have my rectangle there, okay? So now I have that, all right? Now I'm gonna find my foci. That's usually the fourth thing I find. So for a hyperbola, remember it's a squared plus b squared equals c squared. So a squared is 81. So 81 plus 25 equals c squared. So what's that? 81 plus 25, 106. Is that right? That seems huge. Yeah, 106 equals c squared, right? So c is the square root of 106. All right, so now my focal points, right? I'm gonna go from the center, right? The length of the square root of 106. Now, I know that's gonna be 10 point something, right? But if I square root it, because it's just above, that's about 10.3-ish. So I'm gonna go 10 units above here. This is 212, so my foci is 12 and a little bit. Okay, so -4, 12 and a little bit, but I'm not gonna write that. Some of you are writing the decimal here. For your foci, what you should have here is -4, comma, 2 plus the square root of 106, because we can't break that down, and then -4, comma, 2 minus the square root of 106, right? Again, which is, this is a distance of 9, 10, and a little bit. So there's my focus right there. This is my focus right there. So I have that, okay? Oh, my vertices, we said, right, were -4, 11, and then, oops, so put on the next line, -4, -7, okay? Then, so that gave me my C value, so that got added because it's the transverse axis, right, is parallel to the y-axis, so I added that to my y's. And then my asymptote, right, I'm gonna use my center for that, right? So that's -4, 2. And then I need my slope. So again, you can do this one of two ways. If it's transverse to the y-axis, you would know that that's gonna be up A and over B. Or you can just look at your graph here. My asymptotes would go through the center and through the corners, right? So I'm making them dotted because they're actually not part of the graph. Neither is the rectangle. It's just helping us to create our hyperbolas. So if I take a look here, I go through the center, so that's my guaranteed point. And then my slope, right, will be up however much A is, because that's what I counted. So this will go up 9 and over, right, my B value, which is 5. So my slope is 9/5, right? And I would reduce that if I could, but I can't. All right, so my asymptote, and I'm just gonna write it in one, would be y minus 2, which should mirror what you have up in your equation, y minus 2, equals plus or minus 9/5, and then x plus 4, and that's because my center, right, is gonna be my guaranteed point there. And that's in point slope. You do not need to distribute that, write that in y equals mx plus b. You can leave it just like that, all right? Don't do any extra work. All right, so now let's look at the next guy. This guy's a little bit different, again, because we have the x-axis. Oh, I forgot to draw my hyperbola. So this should go through and hug those asymptotes, right? Again, here, go through just the vertice and hug those asymptotes. We shouldn't hit the asymptote, so let me fix that. Okay, but it should be close to it, just like it was with our other graphs. And then the focus is inside, right within there on either side of the hyperbola, okay? So now we have an x-axis one, okay? So if it's x-axis, right, I'm going to find my center. So my center, right, that's the first thing I always find, and you're going to have to state that on your homework. The center is always the opposite, so that's going to be -4, 1, okay? So -4, and then 1. My center. Second thing we're going to find, right, this is my second thing I always find, parallel to the x-axis or x-axis transverse. Second thing are vertices. Well, the positive, right? A squared is 81 because that's my positive term, so A is 9. So if this is the x-axis, right, then I'm going to go in the x direction because that's my transverse axes through there parallel to the x-axis. So I'm going to go 9 to the right. So what's this? 4, 5, so 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Oops, I'm a little outside there. That's okay. There's my vertex. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my other vertex, okay? That's my transverse axes right there if I connect those. So my vertices will be what? -13, comma 1, and 5, comma 1, okay? So that's the second thing I found. Then third thing, right, are going to be the points that are going to help you find your rectangle, okay? So those are based on the b value. So b squared is 9, so b is 3. So from the center, I'm going to go up 3 and down 3. Okay, so that means my 2 points here that I'm graphing, and again, you don't have to state these on your homework, okay? But I should see them graphed because they're going to help you create the graph. So what is that? -4, 4. And -4, -2. Yeah, that looks good. Okay, so then we can create our box here. Okay. Then my focal points, right? So that's when we do a squared plus b squared equals c squared. So that's step 4, right? And you'll see this on my homework. I'll number them. So what's that? 81 plus 9 equals c squared. So c equals the square root of 90. So what's that? 3 rad 10. So always simplify that, okay? So the square root of 90 is a little bit more than 9, maybe like 9 and change. So that means I'm going to count a little bit further. My foci are going to be just outside, just past either of those vertices. And the focal point, I'm going to add and subtract this to the x, because it's x-axis transversed. Okay, so that means when I go to my center, it's going to be -4 plus 3 rad 10, comma 1, and -4 minus 3 rad 10, comma 1. All right, those are my foci. And then I'm going to draw my asymptotes. Okay. And then I'm going to go through and squeeze my hyperbola between those asymptotes, okay? That determines the asymptotes, determine the width, okay? And then my asymptotes, right, will go through the center, right? We had -4, 1. And then my slope, again, this will be now b over a, because this is just the corner point, right? That helps me find my corners. And then this is actually the distance to the vertice. So this will be b over a, or you can just count it, right? So this is up 3 and then over 9. So my slope is plus or minus 3 over 9, which is 1/3. So my asymptotes, and you can write them together, no simplification here. So it should just be y minus 1, which mirrors what's in my hyperbola's equation, plus or minus 1/3, and then x plus 4, all right? And that's our fifth thing we need to find, okay? Now, this should be something you're familiar with, okay? We have a conic section, okay, because I have two squared terms here, written in general form, okay? Now, I know since the x squared and the y squared are being subtracted, this has to be a hyperbola, okay? So when I go to complete the square here, okay, and write it in standard form, I'm going to put together the x's.
These are from way before.
Okay, and then here I have minus y squared minus 2y. I'm going to add the 1 to the other side. And then I'm going to set this up so I can complete the square. So it's x squared minus 2x plus something. You have to always subtract out. This can't be a negative 1 as the leading coefficient. So it's always y plus, I should say y squared plus 2y plus something equals 1. So the big difference here is there should be no leading coefficient to either of these. You're always going to have to factor out a negative quantity for the second set of parentheses because you can't have a negative leading coefficient, all right? So that's different than with an ellipse. All right, so to complete the square, I've got to do a 1 here. And then to complete the square here, I've got to do a 1 as well. But remember, I'm multiplying by this, so it's actually a negative 1 that I'm going to add to the other side, okay? So then this becomes x minus 1 squared minus, and then this should be y plus 1 squared equals, and then these guys cancel, and I just get 1, okay? So now it looks a little bit weird. Because there are no denominators here, but they're both over 1, okay? So A is going to be 1, and B is going to be 1, okay? So I tried to keep the numbers kind of smaller here so we could graph it relatively quickly, all right? Because this video is kind of long, so I'm trying to speed it along here. So I know this is x-axis parallel, so transverse to the x-axis, right? Because that's my positive term. Okay, so that's going to be my A. So then when I go to graph here, my vertices, right, will be from my center. So my center is what? 1, comma, negative 1? Okay, so 1, comma, negative 1 is my center. And then my vertices will be 1 to the right and 1 to the left. So my vertices are negative 2, negative 1, and 0, comma, negative 1, okay? So those are my vertices. I'm just going to write them down below. I said label, but I'm just going to write them down below. And then my corners, right, will be, to create the corners, I'm going to go up 1 and down 1. So that will be negative 1, comma, 0, and negative 1, comma, negative 2. So those will be my corners. And then I create my box. I know it's really small. I'm sorry. So that's my box. So now I will have asymptotes that look like this. And like that, okay? Then my foci, right? Well, I will have for the foci, right? A squared plus B squared equals C squared. So 1 plus 1 equals C squared. So C is the square root of 2. So therefore, if this is transverse, right? Parallel to the x-axis, then that means my foci have to be the square root of 2 from the center, right? So I'm going to do 1. Did I write that wrong? I did this. This should be I think I messed that up. What did I have here? 1. Oh, my graph. Okay, let's switch my graph. Let's double check this. So I did -1. So it should be 1 comma -1. Okay, and then therefore I have 0 comma -1, and then +2, my bad. Okay, and then my corners should be +1, right? And then +1, -2. I was just had my signs wrong. Okay, so that makes my box here. Okay, I have my asymptotes have the same slope as they did before. Okay, they're just going through now graphed the correct center. Okay, so then my foci should be 1, right? Plus or minus rad 2. So if I go here, right, I'm going to go over 1, right? Down -1, but I'll move over here and there for my foci, okay? So then my hyperbola will look kind of like this and like that. And then through here, whoops, and there, okay? So my just so you know, I'll draw it in here. This is your transverse axes. That's what we keep describing. Transverse axes. Okay, you don't have to sketch that, I'm just showing you it. It's the line that passes through the foci and the center and the vertices, okay? Last but not least, we got our asymptotes. So the asymptotes, right? I have to go through 1 and -1. So it's going to be y minus 1, sorry, y plus 1, equals, and then x minus 1. So it's the same. I'm just kind of stealing these here from our standard form, okay? And then I got to find my slope. So I went up 1 and over 1. So it's really just plus or minus 1, or just plus or minus x minus 1, okay? And those are your asymptotes. That's your hyperbola, and we're good, all right? So try the homework. Again, we'll do more practice with this for the next 2 days. This is probably the most intricate of all of the graphs, all right? So there's a lot going on, all right? Email me if you have questions, and I hope you guys have a good weekend.